Hello, my name is Alan Zhang, and this is my lab report for Lab 1, Constant Velocity in the course 2211 with Professor Curtis. So the purpose of this lab is to observe the differences through comparison of the actual position of an object at constant velocity with the position predicted through a program for the same object at the same velocity, constant velocity. In order to compare these two situations, a video of the volleyball rolling was imported into a program called Tracker, which allows accurate placement of the volleyball's position. Here's the video. And in a second, I will show you the tracker software. Here's the tracker software, which recorded the position of the volleyball. So after this, we had to use a program called GlowScript, which would create a predicted in position for the volleyball. And here's a little recording of that. So after the programs were used and the software were used, we got a bunch of data. So we put the data into the Excel sheet, and from the Excel sheet, we were able to create two graphs that would compare the two pieces of the data, and that will be shown in a bit. But to understand this lab a bit more, we have to look into two fundamental physics principles. So that would be the first and second law of Newton's. So the first law is that an object should stay in motion unless acted upon by a force. Following the first is the second, which states that force is a product of mass and acceleration. So why is this important? So these two principles come into play when we are given the volleyball is at constant velocity. So that means there should be no forces acting on the volleyball. And since constant velocity means the acceleration is zero, we see the product of mass times acceleration is zero, which means that according to Newton's first and second law, the force should be zero, which means that the object is in constant velocity. So the very first step of the lab was just to put the imported video into Tracker. So from here we can see that Tracker gives us the position of the volleyball center of mass throughout the time. So this would give us both position and time, which would be then used to find out what the initial velocity is. So here's the calculations for initial velocity, which was just changed in position over time, which would give us 0.529 meters per second. So we needed this value to use in our GlowScript because GlowScript has a parameter that requires our initial velocity, as you can see here. So GlowScript uses our ball's mass, which was 0.262 kilograms, our ball's position, which was found through Tracker, which is 0.201 meters, and our ball's initial velocity, which is 0.529 meters per second. So down here we can see that we have this while loop. So this while loop was used just to calculate the final predicted position. And what it would do is basically it would add onto the ball's position in accordance to the ball's initial velocity. And it would only do it for 0.967 seconds because that's how long the video is running for and how much time the ball had to travel. So here's the graph that we got from the Excel sheet. So we can see that one of our lines isn't very straight. It's a bunch of dots. So in order to fix this, we created a line of best fit, which gives us a rough estimate. And it fits pretty well for how the change in position. So in theory, these two lines should be the same. However, from the graph, we can see that it's not. And to explain this, we need to look at the system and its surroundings. So the system is the volleyball and the surrounding is the floor in the air. Now, to account for the difference of the two lines, the interaction between the system and surrounding would need to be accounted for. So these interactions lead to friction and air resistance, which both act against the direction of motion. So what does this really mean? So this means that while the computational data has a net force of zero, which means it doesn't account for any of that, the experimental model does account for frictional force and air resistance that push against the ball, which means that there is a force acting against it. So on top of that, from this graph, we can see that the values are all heading upwards in the positive y direction. So if we flip the graph around to the point where it's going from left to down to the right, this would mean that the direction of the volleyball would be flipped. So instead of going to the right, which was our positive indicated value, it would be going to the left, which is our negative value. So on top of that, flipping the x-axis doesn't really make sense because the x-axis is time, and you can't really have a negative time. And this brings a conclusion to Lab 1, constant velocity. Thank you.